I'm Joanna Junak and welcome to the latest episode of our GFN Science series featuring Roberto Sussman. Today, Roberto will tell us more about the differences between vaping aerosols and those emitted from a boiling kettle. Roberto, let's talk more about the differences between vaping and smoking. How can they be compared in terms of physical properties and formation processes?
Well, that's one difference between vaping and smoking is that vaping involves a liquid and smoking does not involve a liquid, because in smoking, what is burned, what is combusted is organic matter, right? And in the case of vaping, it is a liquid. It is not organic matter. So the chemical composition of the initial substance is very complicated in the case of smoking. It's organic matter. And the chemical composition in vaping is very simple. It is a mixture of 4 or 5 main ingredients, right? Okay, so what's the similarity between a vaping device and a kettle? The kettle is also has a metallic element, a heating element made of metal. Typically, it's a coil, and it is immersed in a liquid, right? And what's the case in vaping? You also have a coil that is immersed in the liquid. So this is the main similarity, right? The big difference is that the coil, the kettle, will do that, will generate the aerosol from water. And the e-cigarette will generate the aerosol from the liquid mixture, which is different from water, right? So what happens in the kettle? In the kettle, you boil the water, right? I will explain with more detail what is boiling, but okay, you generate water vapor, you boil the water. You don't boil all the water at once. You boil it, you generate vapor from the surface, a certain amount, and then afterwards also, and it is evaporation is this local process. It's part of boiling, right? So, but you generate water vapor. And then this water vapor is inside of the kettle, right? Because the kettle is not 100% full of water. It is a container. It has some area with air, right? So the vapor, it goes into outside of the liquid within the kettle, and then that vapor is going to be at a higher pressure than the pressure outside, because the kettle has a snout, right, that connects to the external air. And the external air is at lower temperature and lower pressure than inside of the kettle. This generates a flow of vapor. It is a mixture of vapor, water vapor in this case, vapor and water, vapor and air. And you generate a flow because of the difference of pressure. And as this vapor moves around, it will cool. And when it cools, you have the opposite process of evaporation. Evaporation is to generate gas from liquid, and condensation is to generate liquid from gas. So what happens when you have a vapor and you cool it? Either because, in this case, because you generate an airflow, right? And it cools. What happens that small bits of the gas condense into small droplets, right? And this is the aerosol. You generated an aerosol because you have a gas flow, which is a mixture of vapor and air, and you have little droplets that are the particles, that they are formed by condensation, right? And, and this is the cloud that you see. Now, the same thing happens with vaping, except that the vapor is not vapor from water. It's vapor of the liquid. And in the case of the kettle, you don't have somebody inhaling the kettle, right? This happens because you generate a pressure, a difference of pressure between the inside and the outside. Here, you have a user that is inhaling. When the user inhales, the inhalation will pull the vapor and will cool it and will generate this condensation of small droplets that will be inhaled. Now, you don't see a cloud because all the vapor goes into the user's mouth. But so the analogy is more accurate for when you exhale. When you exhale, the user exhales the vapor, it is more an accurate analogy with a kettle. Right? So these are the differences and similarities between, see, vaping looks more like producing steam from a kettle than smoking.
And how do the processes of evaporation and condensation work together to form aerosols in vaping?
Well, when you rise the temperature, then you are favoring evaporation, right? Parts of the liquid will evaporate. But when temperatures go down, then this part of this gas, this vapor, will go back to liquid. See, you can also see it in terms of molecules. When you heat, you are increasing the energy of the molecules. And some of the molecules will have sufficient energy to break the bonds that keep them in the liquid. The liquid is more bounded. The gas is free, right? More or less. So you have these molecules here, and you give them more energy, and some molecules will escape, right? So now these molecules are there. But if the temperature decreases, some of these molecules will lose energy, they will collide, lose energy, and will fall back to the liquid. So these are one process is inverse of the other, and they can happen simultaneously. They can happen simultaneously. It's not necessarily that you have evaporation in order to condense or condensation to have. They can happen simultaneously together, or you can also control that by controlling the temperature, controlling the supply of energy.
So, why is water vapor invisible but the resulting aerosol visible?
Well, a gas, when we say vapor, we mean a pure gas. Well, it can be a mixture of gases, but essentially we're talking about molecules, molecules moving, right? Now, what happens? The molecules are very small, and typically the gases are not very dense. For example, a liquid is much more dense. A solid is much more dense, more density. Matter is more packed. A gas, the molecules move around. They have weak forces between them. And so light passes through completely. What's the meaning of something not being visible? Is that the light goes on uninterrupted. There is nothing that is deviating light, absorbing light. You know, light are waves, electromagnetic waves, but they're also corpuscles, photons, right? It's a duality of light. So let's think about photons. The photons just move around, and the molecules are too far away, and the interaction between them is too weak. So basically, it is transparent. Transparent because the light passes through them and gets to our eyes, right? So what happens with an aerosol? An aerosol, for example, we see the vapor from the cloud because we have about 10 million to 100 100 million little droplets that are moving with the gas. Now, 100 million of droplets, but they are tiny. They are maybe, let's say they are about 100 times bigger than molecules. They are very tiny, but there are many, many, many of them. So the light, it's a comparison between the wavelength of the light and the typical distance between the droplets. So in this case, light will be affected because a photon will be coming and will collide or will be deviated. And so there is this optical processes, the light dispersion, right, and deflection. So light rays, when they enter the aerosol, will be deflected. And this is why we see it, right? And now, that doesn't mean that every aerosol is visible. For example, the aerosols that we emit from our mouth when we are talking, these bioaerosols, are not visible because the number of droplets is too small, right? That's why, for example, we say that COVID was transmitted by air, was air transmitted. But if I am talking or if I am breathing, we don't see a cloud coming out of. We can see it in very cold climate for a very simple reason, because the temperature of our mouth is much larger than the freezing temperature outside. So we generate an aerosol from the vapor, not from our breath, right? And so aerosols, biological aerosols, are also invisible because there are too few biological particles that are exhaled, right? But in the case of vaping, in the case of the kettle, in the case of the spray, we have sufficient number of particles to deflect and disperse the light. And this is why we see them.
Stay tuned for the next part of our science series coming in a couple of weeks.